everyone, and welcome to another episode of EVovle, powered by FLO. I'm your host, Gabrielle, and right now I'm thrilled to be joined by Yann Benoit, who's Senior Director of Network Operations, and I'm also joined today by Abel Zacharie, who's actually the Senior Group Manager of Hardware Products. Today, we're going to be talking about how EV charging networks can be enabled to maintain high uptime. So here to enlighten us on the subject, as well as provide actionable industry insights, are Abel and Yann. So gentlemen, welcome.
Thank you.
Thank you.
Of course. Well, to start off, let's kick this podcast into gear by just getting the really big picture out of the way. So ultimately, just why is uptime important? Abel, we'll go ahead and start with you.
Well, if you start, two things. I'm going to go on the extreme, from left being residential charging up to transit charging. And in between, there is workspace, MERB, and all those applications. But basically, from a home perspective, you have a bit more control because you can choose your charger and you can control the charging environment that you have at home. And here, I would like to express the model and to make it understand. Let's say you use a phone and you buy your cable and charger for that phone, and you buy a low-cost one. Imagine the frustration when you want to leave in the morning and your phone is empty because something went wrong with the equipment. At least you have the choice of choosing the equipment. That's from the home. So you can choose a more reliable, maybe more expensive, more durable, easier to install and everything. That's one thing. The other extreme is when you leave your home, and let's say I live in Quebec, and if I'm not taking the train to go into the Montreal office at FLO, I'm going to take my car, and before going, I'm going to charge my car, and then I will be in transit, going to a place where I don't know the charger necessarily, and then I have to get to the charger safely, meaning what was on my app or wherever I wanted to go was accurate. When I get there, I need to get accustomed to the charger that I don't know, that I haven't chosen. I don't know which state it is. And the impact of not having a reliable charging experience is that I will get late to my meeting in Montreal, and so on and so forth. So there's two dimensions. You can choose a charger and control a little bit more your distance and make sure your car leaves home with full charge. But when you go to another place, another city, then there's an added complexity by the fact that the charger is unknown, the payment process is unknown and all this, and it adds to the complexity of getting there on time, and that could be extremely frustrating, and you could have a lot of insecurity in front of using an electric car.
And I want to ask you, Yann, about the business perspective of just why is uptime important?
Yeah, on a business perspective per se, it's really what sets us apart, right? If you buy a car charger, what's the use if it's not working? So basically, it's a commitment that we're making. We're selling a machine, but we're selling a service that needs to work. There's other consideration as well. Not all chargers are owned by, an example, a big corporation. Sometimes cities can buy a charger. Sometimes smaller companies can buy a charger. So for us, we need to make sure that this product that they use will be reliable, that will be useful for their users, and in a sense, secure their investment.
Well, anyone who's been the least bit interested in EVs has probably heard recently about charging network reliability. That's a big topic. Just influencers and media outlets, they talked about it a lot, more so around the holidays. But people pointed out that some networks don't offer a consistent experience. Because like you said, I mean, and it's not just a product. I mean, you're buying an experience. So people are asking better of the industry. So why is uptime still a concern for some networks, and just what are the biggest challenges facing EV charging networks in terms of reliability? Let's go ahead and start with Yann.
Yeah, well, first of all, we've seen that users are getting more vocal about uptime, and it's normal because EVs are now becoming commodities. More and more people use it. We're not in the early adopter mode right now. We're getting into the mass adoption. So some people realize that not all networks are equal, right? What we believe is that any network operator should be accountable for their uptime. It's not enough to install a charger. It needs to be reliable for family vacation, business operation, and all of that. We believe that so much that we recently sponsored a bill in California just to make sure that publicly funded network are also accountable for uptime. So it's good to put money, public money, to make sure that the transition goes well, but more than the hardware, it needs to be reliable. Very, very important. A similar bill will also be adopted in New York City, by the way.
Well, I'd like to corroborate what you were talking about, saying that there's the perception of reliability of network is not so good. Just 2022, there was a survey done by JD Power talking that in 2022 alone, 39% of all visits were unsuccessful. When you think about the challenge of the industry, you have to think about something. A charger is a very complex machine, not complicated, it's a complex machine. There's a lot of electronics, there's cooling, there's mechanical elements that can break and all sorts of things. So it's a complex machine to start with. It's also put in a lot of elements. Very cold weather, like we have in Alaska, where we have chargers, to very warm weather where we have in some place in the United States. So a lot of different climates. To complicate things even further, not the charger itself, but also the fact that they are victim of vandalism. You have in Kharkiv, you have people that break connectors, they cut cables, they roll on cables with their car, they leave them on the ground, and break screens and stuff like that. So chargers are in various places in various areas, and it's not uncommon that they get broken, damaged, and so on and so forth. And here is the key. When the charger is broken or damaged or whatever, or even bumped to by a car or something, anything can happen. The key to reliability is also how to detect that quickly so we can fix it quickly. That's another a challenge. How can we do that? And that's what could be the charger that detects itself automatically, could be other things. It's bigger than the charger itself. On top of that, assuming that the charger works well, assuming that the elements didn't destroy it and the charger is very rugged, operational condition, the next thing related to the fact that you don't know it, you have to activate it. How can you activate it? With an app, you can activate it with a card, you could activate it with a credit card. And also, when you're talking activation, the activation system, the card reader, if there's one, needs to work. And so it is also a component. And on top of that, when you are part of a network, you need to make sure that your card is also compatible with the other network, and we call that roaming. The fact that you are on your network, you need to be able to go on the other network, and you need to do roaming. We at FLO are doing roaming agreements with other networks, so the FLO network members can also roam with other networks. But there's room to improvement. So you see all the challenge. We're having a lot of different challenges to have a successful charging experience, especially in the transit situation where you go from point A to point B and you have to stop in between. So all this is a complicated, complex, includes complex things to understand and mitigate and manage. So just to give you an idea of the complexity that is in front of us, and as Yann pointed, really we are doing a lot to promote reliability, and that's not only the charger itself; it's the whole ecosystem that has to be concerned by this.
Yeah. Oh, so much goes into just the word reliability. What does that mean? Well, I mean, you want to make sure the service is what you're paying for and what's advertised. And I mean, all these challenges you just brought up, whether it be like network compatibility, I mean, geographical locations, or even detection response time, how well you're able to respond to all of these challenges. So how can EV charging networks face all these things we're talking about, but also ensure that their stations are what we're talking about, reliable, but also available to drivers? Let's start with you, Abel.
The thing is that when you talk about a network, you talk about a variety, an ecosystem. That means the owner of the station, that means the person who installed it, that means the network itself, the software, that means the station itself, the communication, the payment, and everything. The first thing we need to do is to find good partners to work with. The fact that we are promoting so much reliability makes us a good partner to work with. So a network will want to work with us, a site owner will want to have a FLO station, and so on. That's the first thing. But the thing that we have at FLO that is very nice is that this ecosystem that includes the station, and the software and the payment and so on, when it's all supplied or provided by the same supplier, which we call vertical integration, that's you increase the chances of having a reliable operation. That's what we do at FLO. The station we design, the test, we assemble, we service, we install. Yann's team will go and install. We commission. In other words, we link ourselves, our stations to our network by our own people. So we control a big chunk of the components in the network. And then we could even go further than that, developing the infrastructure with our division called FLO Infra, where now we take care of the whole site, meaning we also install and we can also operate the station. So we can guarantee the whole, I would say, value chain from the station up to the payment, up to the gun that charges in the car. So that's basically an approach. That's what we have to achieve. And that's what we're trying to do ourselves, FLO.
Gabriel, we have seen partners deploying a number of public charging stations and deciding to use its own electrical technician to service those chargers. So this approach proved to be difficult with the technical challenge, with now widespread workforce shortage, and ultimately station uptime can take a hit. So that can reflect poorly on our customer and on FLO alike, right? So circumstances like this also tarnish the industry as a whole. If we do not maintain well the chargers, if people not skilled enough or knowledgeable enough maintain those chargers, we have downtime. And if drivers hear repeatedly of broken chargers, we think that they're less likely to adopt the EV, of course, right? So in those cases, once FLO assume responsibility for maintenance of the customer's chargers, some cases we've reached an increase of uptime by 1.5%, as high as 1%, 1.5%, just because we did put knowledgeable people, our own people, to maintain the network.
Well, let's kind of switch gears here over to network downtime. So just what are the common causes of EV charging network downtime, and how can they be prevented ultimately? Yann, let's start with you.
It's sad, but one of the most common element is cable damage. Really, this happens a lot. Abel mentioned it. Sometimes they lie on the ground. If depending on the company, some cables don't have a good cable management system. So having a well-designed cable management system that is easy to repair is absolutely critical. The rest, you know what? It's electronics. So making it as easily serviceable as possible, well programmed, connecting those components to a good remote monitoring system is really the key to see problems even before they arrive and have very fast on-site repair.
It can be as just as simple as the cable to be preemptive and being able to solve that. That's just crazy to me. Well, Abel, what do you think are some of the major causes of network downtime?
That's exactly what Yann is talking about, the cable. And that's what we hear also from the headquarters. Most of the cases come cables and then here in Quebec, we have what we call snow blowers, that
Yeah.
goes with the cable. Could happen.
Goodness.
No. That's one of the most severe cases. And when you do statistics and you see at the components that are more or less replaced, it's not because they are not reliable. As I explained earlier, it's not only the station itself. Sometimes a lot of things happen to the station, and then you are in a reactive mode. And when we're talking about preventing, and maybe to present what Yann was talking about in a slightly different form, I come from the automotive industry. And in the automotive industry, something that is big, as reliability in the charger industry is safety. In a car or in a vehicle, we talk about passive safety, and we talk about active safety. Passive safety is when you build a car, you make sure that it will resist to a crash. And it's constructed extremely rugged. So if an accident happens, it will be very, very resistant. Active safety is more about how to prevent the crash, which is how do we use electronics to mitigate or make sure that the crash doesn't happen or it's less severe. So you could think about an active airbag, you could talk about ABS, you could talk about all of these things. When you're talking similarly, how can we do proactive, passive reliability is making sure the station is well designed, the material are well chosen, that it's built in a consistent fashion, that it is installed right. Nobody connected it wrong. Yann's teams, they know how to do this. So as I was explaining, vertically integrated, where you design the station up to the installation of the station and connecting it to the software. In other words, a charge point operator to the network. Just that is already making sure you're secure. Now, from that, what do you do? If something bad happened, two things. Well, there's Yann's team that needs to react quickly, but you need to also be able to monitor if there's a failure. That's more on the active reliability side, where you can detect with we have a group that monitors the stations, and if something wrong happens, you see, oh, that station is red. Something is wrong. Yann, this station is not working right. And then you can quickly fix it. That's now. Later, and even we have some system that could proactively alert. We could troubleshoot, the station can have the ability to troubleshoot itself and sends a message. That also is something, a big area to increase reliability.
Reactive, but also staying active is very...
Yeah, exactly. There are two dimensions, and we need to manage those.
Absolutely. Well, as we start nearing the end of the conversation here, let's take a step towards just overall reliability. What are the steps being taken to improve it on EV charging networks, and just what impact might these measures have on just the future of the EV industry?
Yeah, you know what? Improving reliability is not a one-time job, right? So we could say we have a high uptime and we're above current standard, and our job is done. We don't stop there. We don't want to do that because we want the whole industry to get better. We're thinking about the user and ultimately about the mobility revolution. That's super important for us, and the climate as well.
One of the impact, we can work, and we have worked on improving the station itself, improving the communication on the station. But if we're talking about the industry as a whole, there's FLO and other people. Right now, we know that government, to improve, make it easy to charge, will impose standards and communication between the station itself and the network. In other words, it's going to be like a standard communication. That's going to be the next development. Now, another thing, you're going to be able to take a gun, the pistol, put it in the car, and automatically the car will talk to the station, and there will be communication between both. But that has to be standardized as well. That's on the works. That's going to be the future. So, if we're talking from the ground up, you have the station itself, then connected to the network, and you make sure that all networks use the same standards. So then you're really managing the risk. And that will be the next steps that you're going to see. The future will be standardization in communication protocols between everybody or any part of the network.
Standardization between chargers and car is key, like Abel was saying. But once you have that, you can also have standardization in terms of network talking together and making sure they share the right information, making sure you can do surveillance super easily, whatever the network that you're using. So really key, and that's something that I see will be able to go. We're going to be able to see way beyond what the car industry was doing right now in the oil and gas world, right? Connecting your source of energy with your car is amazingly exciting for the future, I would say.
Well, I think we can all agree on that. I mean, this is ending on certainly an exciting note. I always love talking about where we can see the future heading and just how much progress we're making towards it as well. So that closes up the conversation for today. So thank you, Abel and Yann, for joining us on today's podcast to discuss how EV charging networks can be enabled to maintain high uptime. It was a pleasure to have you on the podcast.
Thank you. You're very welcome.
Of course. And as always, if you want to learn more, please visit FLO.com and look for this podcast wherever it is you get your podcasts at. I've been your host, Gabrielle. Thanks for tuning in.